Good morning, everyone. My name's Ian Ogilvie. I'm here to take you through today some of the storage requirements and changes to EN 15288 because there's been a very subtle change to it as an amendment as far as what we're thinking about when it comes to storage of chemicals. If you're not used to me, I'm actually the chair of PWTAG. I also sit on the BSI committee for the UK and SW136, as well as a technical advisor for the RLSS and a few other bodies as well. And to really start ourselves off today, I just wanted to talk about the history of swimming pool plant room accidents. And for that, I'm not concentrating on what we'd potentially think as drowning, but more as in chemical incidents, problems with chemicals, chemical gas releases. And for quite some time, we hadn't really been keeping a history of these accidents. And it's only been over the last few years now that we've started to establish some of the accidents that have been happening in the UK, where they are, potential hospitalizations and what happens, who happens, but at the same time also starting to look at potentially the, how can I put it, the organization. Is it hotels, is it schools, is it sports centers, is it private industry, sort of looking at more to see who is actually where these accidents are coming from. And I'm going to throw it out to you guys just now, but as a general guess, what do you reckon would be the number of accidents we usually have per year? Where there's a hospitalisation, so to speak, involving a plant room, so to speak. What do you reckon? Anyone got a hazard a guess? 10? We got a 10 here? 10 as well? Anyone higher, lower? 50? Bit Bruce Forsyth here, no? No, it's actually about 7 or 8, believe it or not. But this is a really strange one. In 2022, it jumped up to 19. Okay, and we're not entirely sure why. And since then, actually, 2025, it's only been 7 recorded. So we're back down to the 7 or 8, which, to be fair, is 1 is far too many. Let's be quite honest with you. 1 is far too many. And we don't actually know why. I have personal suspicion as to why I think it is, but whether I'm right or not, I'm not entirely sure. But when we look at the statistics of some of these accidents, so on the recording and the events that we've now done, we've come back, there's been 121 accidents since 1995 to 2024. And we've tried to do some stats on these over a 3-year period. So you can see where some of these accident stats come from, but we're looking at also the time of day of these accidents where we've been able to record it. So it's almost, not quite, but almost an even-ish split, to be fair. Sometimes we haven't been able to record the time, so if you notice, it doesn't actually add up to 100%. So that's interesting. My analogy of this, I honestly thought it might be quite early in the morning, because for those of you who work in plant rooms and pools, and you've seen the person carrying a can of Red Bull first thing in the morning who's half asleep, you might have a bit of an analogy to that, but obviously I was wrong. Some of them are obviously not reported, which is quite interesting as far as the time is concerned, as I said. Also, we looked at this sort of when it is it a weekend, weekday? Again, no really surprise there, because you think weekdays, you've got 5 days, weekends are just 2 days, so no real surprise at that potential stat. In which time of the year it was, as far as months are concerned, again, sort of almost an even split, so nothing really that signifies anything different on that either. And these figures are actually, we record them publicly, by the way, as the instances, and you can see the web address at the bottom where we actually put these on there, and also linked to the CBA as part of our reporting function. But as far as the facility type, if I just pop these up just to try and give you a bit of a spread, we were wondering if it was a particular facility type that maybe didn't have enough training or there wasn't enough expertise in that area. But again, nothing really came forward from that, where you can see we sort of split them into different facility types to try and account for it. But there's one particular accident I just wanted to highlight and bring to your attention that went public a few years ago, which was to do with a hospital, which you can see just here, where unfortunately one of the employees working for the hospital was actually exposed to a chlorine gas leak. Now, to put this in a bit of real terms, you might not know this, but there's only actually 6 swimming pools in the UK that are left that actually use chlorine gas in a raw, neat form as a delivery method, as a chemical. So it's about 96–97% of all pools now in the UK tend to use a chlorine-based disinfectant of whatever choice they want. Yeah. And in this particular case, a private healthcare provider was fined when 3 workers received treatment for falling exposure to chlorine gas, and this wasn't a chlorine gas facility. Okay, so it's not actually a chlorine gas cylinder leaking. Anthony Coombs, an engineer from Sandhurst, Berkshire, was working at the Hampshire Clinic in Basing Road in Basingstoke when he was exposed to a potential deadly gas leak on the 11th of March 2021. Unfortunately, he added sodium hydrogen sulfate. If you're not used to that terminology, we know it's sodium bisulfate a lot of the time, or dry acid. That's its correct chemical name. To sodium hypochlorite, so day tank mixing would be the classic way of me putting this to you. Unfortunately, there was a chlorine gas escape. Now, unfortunately, chlorine gas in significant forms can actually be fatal. Exposure can be over a very short period. It's acidic in air as well. It's a potential. It tends to burn your alveoli sacs. It can cause permanent damage to your lungs at the same time. And the gas produced, you can see there was nearly 8,000 times over the workplace limit, which is the well limits published by the HSE, and 400 times over the immediate dangerous or life to threat through the IDHL limit as well. The group failed to produce a recognised standard, and there wasn't suitable risk assessments in place, adequate training and instruction, a safe system of work for handling the mixing of chemicals. And the group itself, they were fined under Section 2 of the Health and Safety at Work Act. If you're not familiar with that, that's where the employer has a legal duty to the employees whilst at work, which is a Section 2 offence. Fined £160,000 and about £12,500 in costs. And at that stage as well, I would probably also add, I would have expected that the employees would probably have taken out a civil suit as well, yeah, which probably would have been settled out of court. Okay. Now, as part of the change to EN 15288, these are some of the highlights of the changes that actually came about, and I've extracted one of the particular sections and tried to brief it down as much as possible because it is a lot longer. So, in general terms, it says acid and alkalis need to be identified and stored separately. Okay. I think that should be a common sense approach. The chemicals not stored within the plant room ideally is what it mentions. Now, I know a lot of you will be storing chemicals in the plant room. That being the case, keep them at least 1 metre apart. Okay, so that may be possible, depending on the size of your plant room. And if that wasn't possible, you should have separation of the chemicals through a sealed wall, which is at least 800 mil above the highest level point. Okay, and that's obviously to think about splashing and splashover. Now, just be very conscious of that, because I've seen examples where I've seen plasterboard walls, yeah, which are porous. Yeah, remember brick and blockwork is also porous. So it would have to be sealed in some sort of form to be able to stop that from happening. Day tanks should be bunded to 110%. Now, please remember as well, kind of stress this, the bunds should be empty. Yeah, so many times I see partly flooded bunds, so the bund also needs to be empty at the same time. And chemicals stored in multiple drums and containers. Now, this is where you might have carboys as an example. So there's an HSE guidance ruling on this, that you must have 110% of the volume up to 25% of the quantity. Now, let me explain that a different way. Let's say you've got 20 barrels, yeah? 25% of the volume would be 5 barrels. Okay, so you have to be 110% of the 5, which is the quarter value quantity. Yeah, and the reason for that is because what's the chance of 1 barrel leaking? Possible. 20? Probably improbable. And that's the idea, is that you could have that additional leak there. The injection points have to be clearly identified as part of it now. And also the injection lines have to be sheaved as well. And as part of the actual sheaving as well, you now need to show flow direction of the injection line. So that's where the injection line sheaving would have, for example, as an example, sodium hypochlorite with actually a directional arrow on it telling you which way the chemical is going towards the injection point. You can buy these on a roll of tape quite easily and sort of go around the plant room and very easily label it, you know, for a tenner for a roll of tape, so to speak. An injection point should be ideally below head height to minimize when cleaning. So if you do have to clean injectors, imagine cleaning one above the head with the potential for it to fall back on you, where if it's at sort of waist height, chest height, or below, where there's less chance of having backlash onto your face. And ideally as well, there's a dead man's handle for bulk tank and connection day tanks. Now, I'm very aware that a lot of people might not have a copy of 15288, so I just want to pop this up from PWTAG to try and show the alignment with the code of practice and also swimming pool water. And if I just briefly put this back up, this is the information that I've actually extracted from the code of practice and also swimming pool water. And if you almost see, this is a carbon copy because this is what we're basing it off. So I understand you might not purchase 15288, but to look at the code of practice, which is free of charge, or to purchase swimming pool water and go through it, identify your chemicals and put it in there, it's literally a carbon copy of what we want. Okay? Everyone looks so enthralled, don't worry. I'm trying to make this as interesting as possible. Just a little bit more about disinfection and pH control, because that falls in a slightly different section. I've already iterated to some of it. So the dosing system should be specified for the chemical, which I've mentioned. The system designed to avoid any potential leakage. A really good example of this I might show you in a bit of horror photos. Should the dosing system fail or have any abnormal behavior, you should be able to quantify for that. So for example, that would be an injection point that has a non-return valve on it as an example, so it can't backfill from the pull, a four-way function valve that actually functions correctly. The dosing line identification, as I've said. Injection points to be a safe distance apart. So think about this, and there has been instances of this recently, where the circulation pump has failed, the flow switch has also failed in the dosing unit, the chlorine level drops, the system then injects, the pH rises, so then it calls for acid, and then you have basically a quantity of two different chemicals within the pipework that when you realize when you walk into the plant room and it's a bit quiet today and you switch the pumps back on, causes a mixture. So there should be no siphoning, so that goes back to one-way injection. And CO2 systems, if you have got them, should be well vented in an area and often stored outside, which you find, and there could be extract on the system as well. And then there's just one final last part of the section for one more chemical which you'd inject as well, which could be someone injecting a coagulant or a flocculant. Most commonly, most people will probably be injecting polyaluminium chloride pack, as you'd put it. A few nods of the head here. Okay, so hopefully that's there. So automatic dosing would be preferred. As far as front of the filter as possible. So the ideal mixing is supposed to be ideally round about 10 seconds prior to reaching the filter bed, which can be quite difficult when you think about the timing. In a position to ensure even distribution across all filters. So in other words, you put it in a central point and then it maybe splits to 3 filters, so it can distribute quite easily across it. And a position where it's not going to interfere with the analyzer. PAC has a pH level of about 2.6. So if it is injected prior to the sample line, it can give you a fake reading on the sample line as to what you actually have potentially in the water. Because it will actually lower the pH that tiny little bit and it'll give you a different reading. And I say action time usually is roughly about 10 seconds. So these are some of the common problems. These are some of my horror photos that I've taken. Hopefully no one's plant room is in this picture. Matt, no? Yours? No? Just checking. So this was one I recently took in a pool in South London. As you can see, centrally there, as part of this, you can see you've got sodium bisulfate on the left, sodium hypochlorite in the middle, and then PAC on the right. So we've got a lovely combination of acid, alkali, acid. Granted, they're all bonded. But common problem you can see here, they're within a meter of each other. So there should be the separation. So if you look onto the next picture you can see here, so they are within a meter of each other, but they are separated, but what's the issue? It's blockwork, it's not sealed. Blockwork's porous, So should there be a leak from the top of the four-way function valve that actually sprays onto it, there's a chance it would actually seep through the blockwork to the opposite side. A really easy fix. I'm talking about buying some chemical sealant, Perspex, anything else that's applicable. We can actually just add it to the surface of the wall. And this last one here, transfer from spillages. So as you can see, this is calcium hypochlorite stored in an external store. It is actually away from the actual acid itself, but the whole bund itself is porous. Because remember, this is multiples, so it should be a quarter of the value, bunded to 110%, where you could buy something like a bunding tray would be the ideal part for this as well. So there's a difficulty with that one just there, as you can see. The other problem, I'll be honest with you, with this one, there was a lot of trace chemicals being tracked by my feet, across the plant room floor, across onto poolside, across into the changing rooms. Next thing you know, you've got potential for children walking across the floor who are then exposed to calcium hypochlorite on the base of the floor. which in general terms, most of it is a pH value of about 11, yeah, which could possibly cause alkaline burns onto the soles of the feet. Okay, it's like my horror pictures here. But I'm going to have a look at just a few more here. So this is what I said about the ideal example here. So this is a bunding tray, so fantastic, great, this has worked. So that would give us our 110%. Sorry, let me just go back. But can anyone spot the problem just here with this one? This is where I'm supposed to be challenging you guys. Come on, let's get a bit interactive. What's the chemical in the barrel to the right? Any has a guess? It's what, sorry? Okay, it's PAC, polyaluminum chloride. pH value 2.7. Yeah, remember, acid and alkali stored separately. So yes, this time it's been bunded to the tray. Absolutely great, we're happy with that. But they put the acid rule next to it, which means it's within a meter, which means it has to have the separation wall. Yeah. In an ideal world, I wouldn't put a separation wall, I would move the barrel. You know, let's be practical. You don't have to build a wall every 5 minutes. Let's just move the barrel. How about this? So we can see here again, it is using a bunding tray of sorts, wouldn't necessarily catch it, but we've got a chemical to the right, which looks like sodium hypochlorite. Yeah. Then the central chemical you've got there is PAC, polyaluminum chloride. So that's, again, 2.7 is a pH. And then you've got the chemical to the left, which is pH minus, aka sodium bisulfate, yeah, which has a pH value of about 1.4. So again, we're back into the acid-alkali scenario there. I've got to say, one of the best things you can do now quite easily is just simply to use Google or the cost sheets to actually go back to refer to what is the pH value of these. But I'm going to show you what I think to be is potentially the worst picture I've ever seen as far as chemical storage. Are you ready? Everyone's nervous in case it's their plant room. A few nerve parts here. Right, this is the worst one I've ever come across. Right. So let's just, there's a few chuckles I can see. Let's just have a little laugh as to why. Okay, so firstly, yes, it has got a bund, which you can see is the blue one. Yeah? But for some reason, someone's decided to build a brick bund around the bund. I'm not quite getting that just yet. Yeah? But where should they really have applied those bricks? Yeah, in between. And sealed them. Yeah, so that should have really been applied between and sort of sealed them. Okay? So the separation isn't there, which we can see, which ideally should be 800 mil, okay? But because they've built a lovely low wall, my question is, what's the canister in the middle? Okay, it's actually an acid, right? So this is the thought process now. If that falls to the left, we're okay. If it falls to the right, yeah, learn to run and fast, yeah. Because they've actually encouraged the fact that you can balance something in the middle by having such a low-standing wall, which is frightening. Okay? Can anyone spot anything else that's wrong? Go on. Yes, absolutely. It's frightening. So when you think of an injection line, exactly what you said, we put it into what's known as sheathing, which I'll just do like this. So this would be the sheathing line. And the theory is that should the injection line fail, you won't get sprayed in the face and you'll be nice and safe and everything's absolutely fine. But if you notice, the hydrochloric acid is actually sharing the same dosing line as the disinfectant, which means should there be a leak, there's the potential of runoff back into the original storage. That's just awful. And there is actually another error in this one as well, which I'll just pop these up a bit more. It's actually the label, okay? That's not chlorine. Chlorine's a gas. It comes in a cylinder. Yeah. How about I go to the petrol station, I get rid of all the green and the black, and I just change it for blue, and I just put fuel, and we could all have a little sniff of see what it is. Just have a little sniff, everyone, before we do it in there. So it's just unbelievable. What we're trying to do now is trying to use the CBA for our anonymous reporting function, yeah, which is this. Now, we've talked about this a few times. This is available on the PWTAG website. It's completely anonymous. We don't ask for any organizational name. But whether that be just spilling a barrel of hypochlorite on the floor, whether that be a problem with an injection line, a small mixing, a flooding of a day tank, we're trying to identify where we're going wrong in our industry, where we can train better, educate better, and make us more chemically aware. So basically, we don't have problems, and we want to have, and I've said this a few times this week, healthy, safe, recreational water. Because that's what we want at the end of the day. It's branded by some of the chemical distributors, as well as some of the main organizations. I know Chris' example has had his input in this, so have I, to try and have this reporting done. And they do publish reports. Can I also say that we don't hold the information? The CBA, the Chemical Business Association, hold the information, and they publish their annual reports. Sorry, it's a quarterly report, if I remember rightly. They publish the reports. No, actually, it's annual. And they've just published 2025. Yeah. And we try and get them to tell us why it happened and what was the outcome as well. As I say, training's the most important thing for me, as far as when you think about training as a detail. So there's produced guidance in this from the HSE as well, which is a useful resource as part of the whole thing. And also we do have HSG 179 to go back to it. But as well, ourselves at PWTAG, SPARTA, whoever it might be, we are very useful resources for any of you just to email us to ask a question, so we can offer advice to try and help and support our industry as much as possible. Yeah. Everyone's very quiet today. I don't know if I've kept everyone awake. I'd like to say thanks, but if anyone has got any questions, I know the guy's got the mics. If you want to pass it around, if anyone has a question. It's breakfast time. I've maybe bored you all to tears, so that's all right. Anyone got any questions for me on this or not? No? No? I've got away with it today. That's fantastic. Well, listen, thank you for your time. And by all means, if you want to speak to myself, I'll be over in the PWTAG stand. And thanks for your time this morning. Cheers, guys. Thank you.